Hello everyone, in today's lecture we will be talking on handling missing data in data mining. One of the most important stages of data mining is pre-processing. We prepare data for mining. Let's have a look at handling missing data in data mining pre-processing. So what is data pre-processing? Data preprocessing is a data mining technique which is used to transform the raw data in a useful and efficient format. That is, we are transforming the raw data into an understandable format. It is also an important step in data mining as we cannot work with raw data. The quality of the data should be checked before applying machine learning or data mining algorithms. Why we need data pre-processing? Data in the real world is dirty. That is incomplete, noisy and inconsistent. Incomplete means lacking attribute values, lacking certain attributes of interest or containing only aggregate data. Noisy, it means containing errors or outliers. Inconsistent, it means containing discrepancies in codes or names. No quality data implies no quality mining results. Quality decisions must be based on quality data. Data warehouse needs consistent integration of quality data. Major tasks in data pre-processing: data cleaning, data integration, data transformation, data reduction, and data discretization. Data cleaning can be rectified using filling missing values, smoothing noisy data, and removing outliers. Data integration, it means integration of multiple databases, data cubes or files. Data transformation, it means normalization and aggregation. Data reduction, it obtains a reduced representation in volume but produces the same or similar analytical results. Data discretization, part of data reduction but with particular importance, especially for numerical data. Data cleaning. Data cleaning is the process to remove incorrect data, incomplete data and inaccurate data from the dataset, and it also replaces the missing values. There are some techniques in data cleaning. It involves handling of missing data and noisy data handling. Missing values. This situation arises when some data is missing in the dataset. Data is not always available. Example, many tuples have no recorded value for several attributes such as customer income in sales data. Missing data may be due to equipment malfunction, inconsistent with other recorded data and thus deleted, data not entered due to misunderstanding, certain data may not be considered important at the time of entry, not registered history or changes of the data. How to handle missing data? We can ignore the tuple, fill in the missing value manually, use a global constant to fill the missing value, use a measure of central tendency for the attribute to fill in the missing value, use the attribute mean or median for all sample belonging to the same class as the given tuple, use the most probable value to fill the missing value. Ignore the tuple. This is usually done when the class label is missing or many attributes are missing from the row. Here in the table, in the second row, the class label is missing. So what we have to do is, we just remove the second row from the particular table. Now see, the result is we are having the first record, third record, fourth record and fifth record. We remove the record 2. This method is not very effective unless the tuple contains several attributes with missing values. And the second one is fill in the missing value manually. Missing values can also be filled manually, but it is not recommended when the data set is big. Here in the table, in the third and fourth record, the gender value is missing. So what we will do is we will just add m or fill the value m in the particular third and fourth record. In this approach, it is time consuming and may not be feasible for a large data set with so many missing values. The third one is use a global constant to fill in the missing value. That is, global constant like unknown, NA that is not available, and infinity will be used to fill all the missing values. This technique is used because sometimes it just doesn't make sense to try and predict the missing value. So in this particular table, in the third and fourth row, the salary is missing. So we just fill with not available and unknown. That is global constant. We are using global constant to fill the missing values here. If the missing values are replaced by unknown or not available, then the mining program may mistakenly thinking that they form an interesting pattern or concept since they all have a value in common or unknown. Hence, this method is simple, but it is not foolproof. The next method in handling missing data is use the measure of central tendency for the attribute to fill in the missing value. That is, replace the missing value of an attribute with the mean value for that attribute in the database. Here in the table, fourth record's salary is missing. So what we will do is we will find the mean for the particular salary column and we will place it in the fourth record's salary. For normal data distribution, mean can be used, and when we have skewed data distribution, we will use median to fill the missing value. The next method is use the attribute mean or median for all samples belonging to the same class as the given tuple. That is, instead of using the mean of a certain attribute calculated by looking at all the rows in the database, we can limit the calculation to the relevant class to make the value more relevant to the rows we are looking at. Here in the table, we have 5 records and the first 2 records belonging to the designation clerk and the last 3 records belonging to the designation manager. And in this record, one value is missing. So what we will do is, we will find the mean for this particular designation manager alone and we will fill the missing value. In this method, if classifying customers according to credit risk, we may replace the missing value with the mean income value for customers in the same credit risk category as that of the given tuple. If the data distribution is of skewed form, we can use median instead of mean. The next method is use the most probable value to fill in the missing value. This may be determined with regression, inference-based tools using Bayesian formulation or decision tree induction. That is, we use data mining algorithm to find the missing value. To summarize, we use 6 methods to handle the missing data. They are ignore the tuple, fill in the missing value manually, use a global constant to fill in the missing value, use a measure of central tendency for the attribute to fill in the missing value, use the attribute mean or median for all samples belonging to the same class as the given tuple, use the most probable value to fill in the missing value. By using the above methods, we can handle the missing data. Hope you all enjoyed the session. Have a good day.